Now we have done the brute solution. Now we will move forward and will do the binary search on this question. How binary search on this question? How do I know it is binary search? Because we have given the sorted array and we have to find a number. We have to find a number in a sorted array, so we can think of that it might be possible that it is a question of binary search. So let's test it out. In binary search, first we have to to do one thing. We have to find the range. Range is this one, like from this to this. But 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 let's first do this. Like, this is our array. So what we can think of, like, if I notice, if I do a indexing of this 1 0 1 1 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10, if I done a indexing, I can see that till here numbers are repeating. Okay, though then I can think of, like, these indexes are even and odd patterns. So if I do this even and this is odd. Okay, this is even. Okay, no issues. Even, odd, even, odd, even, odd, even, odd. So do you notice this pattern? Before appearing the single element, the pattern was odd, even, odd, even, odd, even, odd. Once this single number appeared, then the pattern changed: odd, even, odd, even. So this pattern is just reversed when the single number is appeared here. Single number is appeared over here. Before, the pattern was even, odd, even, odd. After this, the pattern is just flipped. It is odd, even, odd, then even. See, you can see that. Odd, even, right? the So basically, if I write before before the number which is basically single, pattern is odd, then even. after after that pattern is even and odd. So I can even and odd. So basically, on the recognition of this pattern of changing, I can apply the binary search, and on this pattern I can eliminate the search space. Suppose I am over here something, so I know that I am in the left search space. So to find this, I have to go right or left. I can figure it out on the basis of this pattern and eliminate the my search space. Okay, so let's do it. I know now. Now I have a knowledge about the pattern and how do I eliminate my search space on the basis of this pattern. So let's write down the code. So basically, we have given a nums over here. So let n equals to nums dot length gth. So in the binary search, first step is to know our range. I will take 0. If I take my range as 0, like over here, then high is over here, I think I have to handle a lot of edge cases. It might be possible that my low crosses high, or might be my high is here and low is here, and I end up crossing this. Then I will end up to the undefined array number, unbounded number. So this is the edge case. I have to take care of it, that I will not cross these boundaries, or high crosses low. I have to take care of these edge cases which is present at the edges of the array. So to avoid that, I simply do one thing. I'll take a low equals to 1 and high equals to n minus 2. So it is basically a second element and a second last element. So um, let's apply the binary search, and let's do few check before applying the binary search. If nums I, if current element is not equals to nums I plus 1, okay, then return nums I. If the first element is our answer, then why we need to do the binary search? We can directly return that. And I can do one thing. The nums if the given nums uh, if our n, uh, one thing is I can also think of, if n size is 1, n equals to 1, then only we have a one element in the array, then we don't have to perform the binary search over it. I can directly returns the nums I mean nums I means like nums 0, nums 0, right? Nums 0, right? Then here I will get a I is not defined, so I will do one thing. I 1 is not equals to 2 here, then return 1. And here what you can do, like same nums n minus 1 last element is not equals to second last element, then in that case return last element. Now we have applied, so in these three cases we don't go to binary search, we can directly give the answer. So but apart from these cases we have to do the binary search. Let's write down the code for the binary search. Here low is less than equals to high, and let's do our mid. Here we have assigned the value to the low and high. Low and high, we just need to do the math dot floor here. Let's not forget that low plus high, okay, by 2, fine. Now we have written the code for mid, and at any point if the mid uh, no mid will give me a number kind of index. So if mid value, whatever mid is pointing, whatever it is pointing to any value, if that particular value is not equals to its previous value, and whatever mid value is we got is not equals to its next value, in that case what we will do, in that case we will return this mid value. Okay, apart from this, what we'll do, if it's not the case, we have to now trim down spaces on basis of odd and even pattern. So in that case what we'll do, we have to think like here, like if we are standing in the left space and then there is a possibility the element present in the right space, because once the element present, then this pattern will be flipped. If this pattern is same, if we are on the left search space that, and we found out that this pattern is same like even odd, then we know that the in the left search space this single element does not exist. So if the single element does not exist in the left space which has a pattern even odd, then we have to trim or eliminate this left search space and go to right. So what we can do, if nums mid if nums mid modulus 2 is equals to 0, if it is 0, if it is 0, what is it? It in the left search space, if the current is even, then if the current is even, then its next will be the same one. Okay, it if it's even and nums I value is same, means nums mm, mm, sorry, nums mid value is same as mid plus 1, then you are in the then and if nums mid modulus 2 is equals to 1, and nums mid is equals to nums mid in the left subspace. If we are at odd, then its previous one is same, then it will same its previous one. So what we can do then, in that case, we are in the left search space where the element does not appear, then we have to go on the right to search it out. So we will move the low mid plus 1, and yeah, this is the case. Else we will and the reverse of these condition is the eliminating the right portion. So high will be mid minus 1. Okay, so we have write down the condition of eliminating the left search space and right search space. If at any point we did not find the element, return minus 1. So let's test it out. Okay, we got the wrong answers, and we got basically 1 for each answer, for each test case. Let's see why. Okay, low equals to this, we got this 1. Okay, 1. Okay, what is it? If nums 1 is no, if nums 0 is not equals to nums 1, okay, then return nums 0. I think let's set fine, then we have to submit it. Okay, it failed a test case. Let's see why it failed the test case. We have set the values, low is 1 and high is just second last element. If it's a 1, then return nums 0. If 0 first element is not equals to next element, return 0th one. Last element is not equals to second last element, return last element over here. If low is less than equals to high, math dot flow low plus high by 2, we are doing this. And here we writing also a condition, nums mid is not equals to mid minus 1 with the previous one, and mid plus 1 is not equals to mid. Okay, this condition also fine, nothing wrong over here. Now we are trim downing the space. Okay, we are trim downing the okay. While trimming down the space, we took the value, instead we have to take the indexes over here. Okay, this is the major mistake we have done. We just have to take the indexes, not the values over here. So we just fix it real quick. Let's test it out. Okay, wait. Okay, no, we just have to put nums over here. Nums plus, where is comparing here with the value. So let's see. Still getting wrong answer. Why then low is mid equal? Okay, here mid value, here we are comparing with values, right? So we just have to take care of these things. Let's see. Now it is perfect. Let's try to submit now. Mm-hmm. Yeah, it is submitted now. So we have to take care always these things. We avoid these edge cases by taking our first element and second last element, and we just have to be conscious while doing the mid modulus because we are checking the index value that it is 0 or 1 to figure out the space, and here we are comparing the values, not the index value. So we have to take care of these things.